All right. Can you hear me? Dan, wave if you can hear me. Good. All right. Well, let's begin. Thank you, everybody, for turning up. Like I said, this is, I think, an experimental session. I think not experimental, but it's always good to kind of dry run material before a big conference. In fact, I've done lots of presentations over the years on Power Query and Power Query performance tuning, but I've never been really completely satisfied with the results. Part of the problem is that this is a massive subject and really one that you'd need a couple of days to be able to do justice to. So how do you get it down into the kind of 45 minutes or so that we've got here today? Well, what I want to do is really kind of keep the session scope down to the bare minimum. So I'm going to be talking about tuning Power Query performance for import mode datasets and for data flows. I'm not going to be talking about Power Query Excel. I'm not going to be talking about Power Query in any of the other tools. I'm not going to be talking about tuning the analysis services engine inside Power BI. And part of what we're going to talk about, first of all, is understanding what Power Query does and what else happens during a refresh. And we're not going to be talking about direct query. So it's going to be purely Power Query. The next thing is, well, how do we break that down? The more I think about it, the more I am completely clear that a lot of the reason why people find performance tuning Power Query difficult is because they don't know how Power Query works. Power Query seems very straightforward and very easy, but it's one of those things that when you look under the covers, it still works in a fairly easy to understand way. It just works in a completely counterintuitive way. The things it does are the exact opposite of the things you would expect. So before we can really do any tuning in Power Query, first of all, we've got to understand what happens when a Power Query query executes. So what do we mean by a Power Query query? What takes place when, and so on. Then we can answer another important question, which is, how do I know how long stuff is taking in Power Query? Because if you're doing performance tuning, you really need to know how long something takes before you tune it. Because if you make a change, you want to see that that query running faster. And again, that's not anywhere near as easy as it should be. So we'll talk about the ways that you can measure how long Power Query takes to do something. And then we'll get on to the specific topics that I want to talk about how you can actually go about tuning Power Query. We'll talk about query folding. We'll talk about in data flows, computer tables, and the enhanced compute engine. We'll talk about memory usage, reducing memory overhead and buffering. And then towards the end, I've got a couple of slides talking about various kind of random tips and tricks, and I'll have some demos picking up some of these issues. And then the final thing I'm going to talk about is stuff that happens in Power BI Desktop, which doesn't happen anywhere else. It doesn't happen when your dataset refreshes in the service, but which can make your Power BI Desktop experience particularly slow, and what you can do about that. All right, let's start with the scoping. So I want to talk about just performance tuning Power Query, but really, I think what most people care about is performance tuning refresh of their data flows and refresh of their Power BI data sets. And if we take a Power BI data set, first of all, there are actually three separate things that you could tune when you think about tuning your dataset refresh. Because inside Power BI, you have the analysis services engine running. And when you refresh your dataset, it's the analysis services engine that goes away, requests the data, brings that data back, and then builds lots of in-memory structures. And getting that data, bringing it back, building in-memory structures, that's work that takes a lot of time sometimes. And building those in-memory structures is something that happens purely inside the analysis services engine. I'm not talking about that though today. Now, the act of getting the data goes through the Power Query engine. And of course, Power Query could be used for doing various different transformations. That's what I want to focus on today. But Power Query itself has to get its data from somewhere, external data sources, text files, relational databases, whatever. And sometimes the things we do with refresh can take a long time in those data sources. Certain transformations can take place there. It can sometimes just take a long time to get the raw data from an external data source. And again, I want to put that a little bit out of scope as well. So it's this middle part of the diagram that I want to focus on, just the Power Query engine. This is a Power BI dataset. Something very similar happens with Power BI data flows, except the end result is not, or the final destination is not the analysis services engine in Power BI. It's just files stored in ADLS Gen 2 storage. So there's less happening there, and it's more important to focus on the Power Query engine because that's pretty much what's doing all the work. There is one complication. Still not seeing the Power BI desktop. Yes, so Power BI desktop in the diagrams, I'll talk about towards the end. But if you think about what we're talking about here, this all takes place either inside Power BI desktop or inside the Power BI service. So we've got data flows here. These are kind of classic data flows. There is one complication. If you're using data flows with Power BI Premium, you have the enhanced compute engine available. And with the enhanced compute engine, you're still getting data from data sources, going through the Power Query engine, dumping that data in ADLS Gen 2 storage. You've just also got the option of adding these two steps towards the end, where you can take data that's been staged in ADLS Gen 2 storage, have it loaded into the enhanced compute engine, which we'll talk about later, do more transformations in Power Query there, and then output the results in ADLS Gen 2 storage again. So again, I'm going to concentrate on the Power Query part of this diagram and not about the external data sources or however long it takes to load data to ADLS Gen 2 storage. The next thing to consider is where are your Power Query queries executed? Because where they're executed can have a big impact on performance because they execute on some hardware somewhere, and the spec of that hardware, for example, has an influence on performance. If you're thinking about Power BI Desktop, well, everything that I've just said about data sets, well, that happens inside Power BI Desktop when you're developing. More interestingly, what happens when you've published your data set up to the service or you're running a data flow in the Power BI service? Well, if you're connecting to cloud-based data sources, then the Power Query engine executes in the cloud inside the Power BI service. So that is fairly straightforward. If you're working in Power BI Premium, then more resources tend to be available and performance may be better. The interesting thing to point out, and something that people don't always realize, is that if you're connecting to an on-prem data source, or if one of your queries combines data from an on-prem data source and a cloud data source, then those queries have to go through an on-premises data gateway, which has to run on a server that you own and configure. Now, when you get data from an on-prem data source and do transformations on it, those queries are executed on the on-prem data gateway machine, not in the Power BI service. And the Power BI on-prem data gateway allocates more resources to your Power Query queries, depending on how much CPU and how much memory you've got available on your gateway. So the spec of your gateway machine can have an influence on how fast your Power Query queries run. We'll come back to these topics a little bit later, but generally speaking, if you're going through a gateway, it is a very good idea to not only give the gateway as much memory as you can afford, but also as much CPU as you can afford. That will not only help you have a large number of concurrent queries, but the more memory available in particular on the gateway machine means the more memory available for an individual query execution, which can have a big influence on performance. Now, another interesting topic, and this is, I think, perhaps one of the biggest misconceptions about how Power Query runs, is when you have reference queries. So what I've got here is a diagram from the dependencies diagram inside the Power Query editor and Power BI desktop, showing three very simple queries. I'm connecting back to a local SQL Server database. I'm getting data to a query called dimdate, and that query is referenced by two other queries called Mondays and Tuesdays. Now, I've got the actual Power Query queries here. So let's go to Power BI desktop, wake my mouse up, come on, and go to the Power Query editor. And that wakes up. So here's the dimdate query. You can see that I have not labeled load, it's in italics here. So this is not going to be loaded to my data set. And all I'm doing here is just getting all of the data from the dimdate dimension table in the AdventureWorks database inside SQL Server. So I'm just getting a single table. This is a date dimension table. And then this query is being referenced by two other queries, one called Mondays, which simply filters this table. So I only get the rows which are Monday. Got another query here, which filters this data and only gets the rows that are Tuesday. Now, when I load these two tables to my Power BI dataset, how does everything work? How does everything get evaluated? Let's go back to my slide deck. If you look at the diagram, the most natural thing in the world to assume is that when the dataset is loaded and the Mondays and Tuesdays table is populated, the data flows from SQL Server towards Power BI. So we get the data from SQL Server. All of that data goes through the dimdate query. And then at that point, we have all of the data from dimdate, and somehow the data then moves to Mondays, and it gets filtered by Monday. And the same data that lives in the dimdate query is also kind of split off into Tuesdays. This is not how Power Query works. Power Query works differently. Now, does it work differently for a good reason? Yes. And in fact, the way it works, well, I saw Dan's comment about it breaking his heart. Actually, there is a good reason for it to work the way it works. And I'll kind of explain that a bit later. But this is not how it works. How does it actually work? Last animation there, as you do. How does it get executed? Well, we've got two tables that are being loaded into our data set, Mondays and Tuesdays. When the refresh takes place, both of these tables and the queries associated with them are refreshed. Now, when the Mondays table is refreshed, it gets the data from SQL Server. It goes through the dimdate query and goes towards Mondays. When Tuesdays is evaluated, the same thing happens. We go back to SQL Server, we go to dimdate, and we go to Tuesdays, which means, just to be clear, the dimdate query is evaluated twice. Once when Mondays is evaluated, once when Tuesdays is evaluated. This seems terrible. Why am I evaluating things this way? Well, like I said, there is a good reason. And in fact, the way Power Query does things is actually more efficient most of the time. It's when it isn't efficient, that's when you kind of try and understand what's going on, and it seems really bad. But trust me, I will explain a bit later why this is efficient. So effectively, when we've got these two queries being evaluated, sorry for my poor art, but you can see the blue line represents everything that's evaluated when Mondays is refreshed, and the red line represents everything that is evaluated when Tuesdays is refreshed. So why does it work like this? This actually kind of leads on to the topics that I'm going to talk about next, which is streaming semantics and query folding. They are actually more or less the same topic. Query folding is pretty famous. Streaming semantics is definitely not famous, but it is actually, like I said, really basically the same topic. And it all boils down to the fact that even if you look at a particular Power Query query, you see a list of steps inside the Power Query query, it's natural to assume that Power Query evaluates your queries from the first step, the second step, to the third step, to the fourth step, to the fifth step. That is not the case. In fact, when Power Query runs and a query evaluates, it evaluates from the last step backwards. So it evaluates the last step, looks at the dependencies of the last step, goes back to the previous steps that depends on, evaluates them, goes back and back and back until it gets to the first step. This is what I mean by streaming semantics, but it is extremely difficult to get your head around. So let's have a look at a query that I think illustrates nicely what streaming semantics mean, and indeed kind of lazy evaluation, because I saw that come up in the comments. So let's go to the Power Query query editor here, and let's take a look at this query. Now, I'm going to show you some M code, which might look scary, but please don't be scared. It is actually fairly straightforward. Now, what have I got here? I've got a query which at the moment, it's got some stuff commented out, has got 3 steps in it. Step is a list, which is something like an array. You can think about it as a table with 3 rows. It doesn't really matter too much. But this list has got 5 numbers in, 1, 2, 3, 4, and 5. The next step defines a function. We can define our own functions in Power Query. And this function simply takes a number and then waits for a second and returns exactly the same number. So it doesn't do anything clever. All it does is a way of inserting a kind of 1 second delay into a particular transformation. And then the third step here simply loops over this list of numbers with 5 items in, and it calls my function for each item in this list, and then returns the result. So it'll return effectively the same list of 5 numbers, but every time it hits one of these numbers, for each of these 5 numbers, it's going to call a function which inserts a 1 second delay. Now, if you think about this, how long will this query take to run? It's pretty obvious. It's going to take 5 seconds or thereabout, because it's got 5 numbers in a list. It's going to call a function 5 times that takes a 1 second each time, and then it's going to output 5 numbers again. So let's go back to here. Let's go to the Home tab. I'm going to click the Refresh Preview button and count with me when I click Refresh. I'm going to say 1, 2, 3, 4, 5. Maybe I was a bit slow, but that's 5 seconds pretty much. So it worked as I would expect. Now, this all makes sense regardless of how you think about Power BI doing evaluation. I'm going to add a little bit of extra code here. I'm going to add a new final step called first value. The previous version of the query returns a list of 5 numbers. Now what I'm doing is say, just return the first item of that list. So we start off with a list of 5 numbers. And then the last thing I'm doing is saying, well, I only want one of those, so give me the first one. Now the question is, how long is this query going to take to run? And this is absolutely crucial to understanding how Power Query works. Because if you think about, if you assume that Power Query starts at the first step and goes to the end, well, it starts with 5 numbers. We call the function 5 times for each of those numbers, and then we just get the first item in the array. Well, that means that it would probably take 5 seconds to run again. In fact, what happens is this. I click done. It's going to refresh. It's instant. It's taken just a second. Why is this? It's because when this query is evaluated, what do we want to return? We want to return the value of first value, which is this. This says, give me the first one item from the list, which is returned by call function. There's the function that loops over the 5 numbers and calls the 1 second delay. But the Power Query engine is clever enough to understand that I only want the first item in this list. So instead of looping over all 5 items of the list and calling the function 5 times, it's just going to do that loop once, because it's able to look from the end backwards. It knows we only want to get that last item in the list, so it only calls the function that takes 1 second once, and so on. So this is how Power Query queries evaluate. If I had another step in here that didn't do anything, like for example, I just went to call function back here, first value as a step wouldn't even be evaluated because I'm not even referencing it in the output. So this is what I mean by streaming semantics. And this is absolutely crucial to understanding how Power Query queries perform, because you've got to understand that it doesn't necessarily work the way you expect it to. That's going to go back to taking 5 seconds now, if I didn't do anything. All right. Streaming semantics. Streaming semantics doesn't apply just inside a Power Query query. That method of kind of taking everything that happens inside a query, compiling it all down to a single operation, being clever about it, that can be even pushed back to the data source. And that's what query folding is, basically. We'll come back to query folding in a moment, though. So at this point, we know what happens when a query runs. So we can understand roughly what happens inside the Power Query engine. So we can start to think about tuning it. The next question is, how long does a query take to run? Now, I work for Microsoft. I'm now going to apologize for the fact that it really should be a lot easier for us working in Power BI Desktop or in the Power BI service or in dataflows to understand how long a query takes to run. It's pretty fundamental. It's not really all that easy. If you're working in Power BI Desktop, then in my opinion, SQL Server Profiler is the tool you need to understand how long a Power Query query takes to run. So let me show you what I mean by this. So let's go back to Power Query Editor. Ignore these, but these are our 2 queries, Mondays and Tuesdays, which get our data from SQL Server. I'm going to go and close and apply the Power Query Editor. I'll apply changes. It's going to ignore that. That's just it, kind of refreshing the metadata. But now, if I click the refresh button, both of those queries will be evaluated. How long do they take to run? Well, there isn't anything in Power BI Desktop. So what I've got is SQL Server Profiler installed. This is something that you can get installed as part of the free download with SQL Server Management Studio. I would say it's an essential tool for anybody working with Power Query. It is available to be accessed as an external tool as well, and I've got the external tool that automatically opens SQL Server Profiler. The reason why Profiler is so useful is that it not only connects to SQL Server, it also connects to analysis services. And as I said earlier, there is an instance of the analysis services engine running inside Power BI Desktop. So when I click this button, I'll be able to open up SQL Server Profiler and have it connect directly to the analysis services engine running inside Power BI Desktop. Now, at this point, I've got to ask, well, what are the events that I want to capture? What I'm going to capture are the command begin and end events. And I'm going to capture the progress report begin and progress report end events. And click run. And now if I go back to Power BI Desktop and click refresh, the analysis services engine is going to say, I want to refresh the Mondays and Tuesdays tables. That's going to kick off an analysis services job, which is going to not only build my analysis services tables, but it's going to go to the Power Query engine. it's going to go away and get the data via Power Query from SQL Server. So that's going to take some time. Now, if we go back to Profiler, a whole bunch of stuff has been captured here, but let me show you the important stuff. A lot of this is purely there for the analysis services engine, which we can safely ignore, at least for today. If you were tuning the analysis services engine, this would be incredibly useful. But I'm just going to get the text data column, the duration column, drag them over here. And there are two things to look out for. The Power Query engine actually returns kind of performance metrics in two separate steps. And this is recorded here in Profiler. The first thing that happens when the analysis services engine gets data from the Power Query engine is that the analysis services engine records how long it takes for the first row of data to be returned from the data source via Power Query. And this can be found here on this row. So there is a progress report end event called execute SQL. And this is going to be one of my Power Query queries. From the looks of things, it's the Tuesdays query. And this took 6 seconds, 5,946 milliseconds. So this is how long the Power Query engine took to return the first row of data. After that, there is another event which says when was the last point that the analysis services engine received data from the Power Query engine. And that is given by this read data event here, where we are finished reading data from the Tuesdays table. Now, it only took 152 milliseconds for the Power Query engine to return everything between the first and the last row of data, but it still took 6 seconds for the Power Query engine to return the first row of data. Depending on the transformations you're doing, depending on the data source, it might be extremely quick to return the first row of data and extremely slow to return all of the rest of the rows of data, but it depends. But these are the two numbers that you need to look for, and these are the two numbers that you need to optimize. In this case, there's also another execute, that there'll be a separate set of events for the Mondays table. But this is how we can see in Power BI Desktop how long the Power Query query takes to run. If we're thinking about data flows, we've actually got a much better situation. Now, I have to be a little bit indirect here. I have got a data flow that does exactly the same thing. Is that gone? Okay. That returns the Mondays and Tuesdays. If I was to run this in the Power BI service, I've actually got much better metrics for returning how long the query runs, but not in here. This is only the Power Query editor. What I need to do is go to the main Power BI screen, and I'm going to have to go to a separate tenant because there's something I'm not allowed to show you in the Microsoft tenant for here. But if I go to my Chrome, if I can just take any data flow here, I can actually get a refresh history by going to look at refresh history and downloading this CSV file that can be found here. Now, it's a CSV file. A CSV file is not really going to be very easy to read. For the same query that we just looked at, it looks like this. Trying to work out what's in what column is not very friendly. So obviously, what I would do is take this CSV file and use Excel Power Query to load it into Excel, which I've done here. And now you can see very, very easily when the same queries are executed inside data flow, I've got one row for every single query inside the data flow. And I can see that there is a duration column that told me that both of these queries took 13 seconds. I've also got some interesting metrics about the amount of memory used, the amount of time the data flow took to wait before it could start running, whether the enhanced compute engine was used or not. So that's how we can actually find out how long query takes to run. I should mention that we do have something called Power Query Query Diagnostics. I don't really have enough time to show it here, and part of the reason I'm not going to bother showing it is because I don't think it's actually really very useful for performance tuning Power Query. It does show some useful stuff, but frankly, it's complicated, and I don't really use it all that much either. All right, so we know how long a data flow and a data set take to run, and we know how to measure the Power Query performance part of it. The next thing is, well, what can we do to improve performance? So we've got our data flow, we've got our data set, we can see that it's slow, and it's slow because of something in the Power Query engine. What can we do to actually make it faster? Well, the first thing is to also understand that the type of data source could be taking some time. You know, what we've done here is we've seen how long the Power Query engine reports to kind of return its data. But as I said earlier, and I showed in those diagrams, what happens in the Power Query engine also includes time spent in the data source. It includes how long the data source took to return any data. It's not always easy to see how long a data source takes to return data. Sometimes you could use, again, SQL Server Profiler to look at the SQL queries that are being run on SQL Server. You can use tools like, for example, Performance Monitor to look and see how long it takes to read data from a text file and so on. But generally speaking, if you want to improve the performance of reading data from a source, it's all about the choice of data source. I would say that reading data from a relational database should always be your first choice to make sure that things run quickly. And if you're reading data from a relational data source, Power Query is going to be spitting out SQL queries, which can be optimized like any other SQL query. So get your DBA to go and look at the SQL queries that are being generated and build whatever indexes are necessary. If you're getting data from other sources, there's going to be a performance overhead. But other sources, they also depend. Generally speaking, if you're getting data from text files, CSV files should probably be your choice. They are going to be a lot faster than JSON files or XML files or even Excel files. Excel files are possibly the slowest data source you can use in Power Query, so I would try and avoid them. Getting files from SharePoint can also be super slow because you have to go through SharePoint APIs. Web services are often slow, and if you're getting data from somewhere a long way over the internet or a long way over the network, that latency can also play into things as well. So choosing a fast data source is the first thing you should do to speed up your Power Query queries. Now, let's go back to talking about query folding. Query folding is one of the most important things you can do to improve performance. It doesn't always improve performance. I have seen some rare occasions where it makes performance worse, but pretty much always it makes performance better. So what is query folding? Well, query folding goes back to what I was talking about earlier about streaming semantics and how Power Query executes queries. Thinking about that Mondays and Tuesdays query, why was dim date run twice? What was the point of it? Well, this all comes into the question of query folding. So query folding describes how that action of kind of streaming data or compiling how all of the transformations in a Power Query query get done. It describes how that can also be pushed back to the data source. So rather than try and explain it, let me show you. If I go back to Power BI Desktop, we've seen our Mondays and Tuesdays queries. We've seen how they get data from SQL Server. I'm going to go to Profiler again, and I'm going to stop this trace, and I'm going to close this. I'm going to start a new trace, and this time use Profiler for the purposes it was intended, which is to connect back to SQL Server. We connect to SQL Server, and let's just have a look at the T-SQL that is generated when my two queries run. So some extra stuff is going to happen here, but let's go back to Power BI desktop. Right, I've gone past it. There we go. And refresh. This should be nice and fast. It's going away, getting all the data. It's getting a couple of thousand rows each. And let's go to Profiler. And apart from a whole bunch of other stuff that seems to be happening, we go down to the end here. You can see that instead of going to the dim date table, getting all of the rows of the table, and then somehow filtering them inside the Power Query engine, for the Tuesdays query, it's generated a SQL select statement that has a where clause, only getting the rows that are Tuesday. And for the Mondays query, it's generated a similar SQL query with a where clause where English day name of week is Monday. And ask yourself the question, would it be more efficient for Power Query to grab the whole of the dim date table with however many thousand rows it is, store that somewhere locally, and then do the filtering itself so that we only get the rows which are Mondays or Tuesdays? Or would it be more efficient just to run these two queries against SQL Server? I think you probably agree it's more efficient in this case to run both of these queries against SQL Server. So this is query folding. This is the way that the Power Query engine can take all of the transformations in your queries and push them back to the data source in a way that is generally more efficient. Now, folding doesn't happen with every single data source. It only happens with databases, generally relational databases like SQL Server. It also happens with some other non-relational databases, like, for example, Azure Data Explorer, or indeed analysis services if you're connecting to that. It will happen with OData data sources. OData is a type of web service. You can also make it happen now on dataflows, but you've got to use the new connector. So Power Query can only push transformations back to the data source if there is a data source there that actually has a query language that Power Query can generate. Second, it's only possible for some transformations. You know, something like a simple filter, yeah, we can translate that to SQL. But of course, there are going to be some things that we can do in the Power Query editor that the Power Query engine can't translate back to SQL, or may never ever be able to translate back to SQL. And when that happens, well, you know, some folding might happen, but other transformations might result in the data being loaded into the Power Query engine and the transformations taking place there. Finally, there can be some other things going on like data privacy settings, which I don't want to go into too much detail. I have a whole hour-long presentation recorded somewhere about data privacy settings that can also stop query folding from happening. Now, unfortunately, Power BI Desktop doesn't really give you a good indicator of kind of what's going on with query folding. You can see in Power BI Desktop whether, to a certain extent, for some sources, whether query folding is happening by going into the Power Query editor and if I click on Mondays and right-click on View Native Query here, you can actually see the SQL query that's generated. But in other cases, query folding will happen even if View Native Query is grayed out. So it is a really common misconception that View Native Query tells you whether query folding is happening. That's not the case. If you see a query here, then yes, query folding is happening. But even if you don't see a query, query folding may be happening. So realistically, you'll have to look at your data source, or in fact, if you look in query diagnostics, you know where to look, that can tell you sometimes whether query folding is happening. The good news is that data flows are actually a bit better at telling you whether query folding is happening, or indeed how streaming is happening. So if we go back to the browser up here, there's exactly the same query happening inside a data flow. We have a look at Mondays. we've not only got the view data source query option here, which is the same as view native query, we've got this thing called view query plan. Now, a query plan sounds very complicated, and it is a little bit complicated. There's some great documentation there, but basically what this shows you is what can be streamed and whether indeed query folding is taking place. We'll wait a little bit for this to appear. This seems to be a touch slow today. But basically what we can see here in this diagram, if I expand this, I've got two nodes in my diagram, and I can see here that this represents everything in my Monday query, including everything that was from dim date. I can see the query, and this remote sign up here tells me that, yes, this was completely folded, which is great. Now, like I said, there are some things that you can do that will stop folding happening. For example, one thing I know that stops query folding happening is adding an index column. So if I add that onto the Mondays query here and add an extra step, there's an added index column. And if I right click and view query plan, what we will see here, when this comes back, is an extra node for my add index column. Now, the good news is here that the data was still streamed to it, but now query folding is not happening. I've also got a nice indicator here with this little kind of red icon here. That tells me also that this stopped query folding happening. The where clause was still folded back, but this added index column happened inside the Power Query editor. So data flows have got a little bit more mature functionality here. So always try and make sure that you're using a data source that can support query folding, and always make sure that query folding is happening. Because like I said, the more of these transformations you can push back to your data source, the faster things are likely to be. Moving on from query folding, but something that's also relevant. I mentioned earlier that with data flows, we've got the option of using the enhanced compute engine. What does the enhanced compute engine do? Well, if I skip back to all my slides, go back a long way, here's what the enhanced compute engine does. It allows you to take data which has been output by a Power Query and store that in effectively an Azure SQL database running inside the Power BI service. So if, for example, I was to take dim date, at the moment, the way the data flow is set up, dim date is executed, the data flows through dim date twice, once to Mondays and Tuesdays. But with the enhanced compute engine, I've got the option of doing the opposite. I've got the option of doing what I thought might have happened in the first place, which was get all of the rows from dim date, dump that, in this case to my data flow, and then build some queries on top of that. And when that happens with the enhanced compute engine turned on, dim date will get loaded into the enhanced compute engine, which in fact loads the data into an Azure SQL database. And then when Monday and Tuesday are evaluated, those queries get the data from the database that it's being loaded into. And of course, because it's an Azure SQL database, the queries fold, and potentially this performs faster. It all depends on whether it's faster to get everything from dim date, dump it into my data flow, load that data into the enhanced compute engine, and then run optimized queries on top of it. It will depend. Go back to my data flow and go back up to here. At the moment, the enhanced compute engine is not going to be used because, as on desktop, dim date is not being loaded anywhere. To allow the enhanced compute engine to be used, I actually have to load the data for dim date. So I click enable load. When that happens, you can see that the icons change on Mondays and Tuesdays. This tells me they're computed entities, and this means that the data from Mondays and Tuesdays will go against that copy of dim date, which is staged inside the data flow. Will this perform better? Maybe, but not necessarily. right. Go back to where we were. The last big topic that I want to talk about is memory usage. And this is perhaps and that is a premium feature, yes. This is perhaps one of the most significant but least understood topics in Power Query performance. Because when a Power Query query runs, it runs in what's called a mashup container. You look in Task Manager when Power BI Desktop is refreshing, you'll see these mashup containers as separate processes running on desktop. This happens in the Power BI service, this happens on the gateway. Now, these mashup containers are effectively limited in the amount of memory that they can use. If your Power Query query running inside a mashup container tries to use more memory than is available, it'll still work. It's just that paging will happen. There's a finite amount of physical memory that a mashup container is allowed to use, but of course it can start to use lots of virtual memory. But we know that paging is a bad thing for performance. So it is really important when you're executing a Power Query query that it is not use more memory than is available for the mashup container. Now, the amount of memory that is available for a mashup container varies depending on where you're executing it. In Power BI Desktop, you can actually modify how much memory a mashup container uses by quite easily going to File, Options and Settings, Options. This wakes up. And changing this. By default, it'll be 432 meg. We're working in desktop, bumping this up perhaps to a gigabyte, assuming you're not trying to do too much in parallel when you refresh, could make a massive difference to performance. In the Power BI service, you don't really get a chance to modify this. You did with Power BI Premium Gen 1. It's not available as an option in Power BI Premium Gen 1, Gen 2, but generally in Premium, you get more memory per container than you would do in Shared. On the Power BI Gateway machine, this goes back to what I was saying earlier, where the amount of memory available for a single mashup container depends on, or is calculated relative to the overall amount of memory available on the entire gateway machine. So even if it doesn't look like your gateway is under memory pressure, increasing the amount of memory could improve performance of your refreshes because it'll mean that a larger amount of memory is available for a single mashup container and a single Power Query query. So that's how memory gets used. What can you do to affect this? Well, there is a famous function inside Power Query called table.buffer, which is perhaps one of the most dangerous functions in Power Query. This actually allows you to force a Power Query query to buffer a table in memory. A lot of the time when you see it, it seems to be a magic solution to overcome performance problems. And that's because it means that you might not be going back to a data source multiple times to get data. You might just be staging a chunk of data in memory and then getting little bits of it very efficiently. The problem is that if you buffer a table in memory and that uses more memory than your mashup container has got available, that can be catastrophic for performance. So don't, whatever you do, use table.buffer unless you're really sure what you're doing. Perhaps more relevant is the fact that some transformations like merges or sorts or pivots or on pivots actually have to buffer data in memory. You're going to be able to sort a table, you have to have the entire table buffered in memory to sort it, unless of course that sort gets folded. So it's important to understand that that I think in my opinion is one of the primary causes of poor Power Query performance. You're doing something like a merge or a sort, it needs to buffer a really large table in memory, and that's more memory than you've got available for your mashup container. Now, apart from trying to change how much memory is available for a mashup container, the other thing you can do is actually to try and reduce the size of any tables that you're using these transformations on. So the classic example would be if you're sorting a table or you're merging two tables, it's really important to remove unnecessary columns. Probably try and do it before the merge takes place. You know, sometimes you can do it afterwards and it'll still be optimized, but try and do it as soon as possible to avoid any of the other scenarios that could cause buffering to take place. Because reducing the number of columns, reducing the number of rows, reduces the size of the table in memory, reduces the chance or that you're going to run out of memory and force paging to happen, or reduces the impact of paging. So reducing the amount of memory is really, really important. I'll have a demo on that in a moment. But really, the last couple of slides I've got are things where there are kind of lots and lots of obscure tips and tricks that need calling out. I've got some references to blog posts here. I'll make sure you get the slides after this. But there are a number of different options that I and other people have blogged about on various different connectors, which can affect performance. Some of these are default, some of them are not default, but just to call out one. If you're connecting to files in Azure Data Lake Storage, you will go through the Azure Data Lake Storage connector. And by default, when that connects, it reads all of the metadata of all of the files in the container, regardless of whether those files are actually in the folder that you're interested in. And sometimes that can take a really long time if you've got a large amount of files. Simply by using the hierarchical navigation option on Azure Data Lake Storage, which simply just changes how the connector displays files inside folders in Azure Data Lake Storage. This can massively, massively improve refresh performance when you're getting files from Azure Data Lake Storage. And there are various different options available there for different connectors. Other things to call out, well, if you remove duplicates from a column before merging and aggregating, that can improve performance. I've got a blog post on that, there's a link there. Two that I'm going to show you that are quite interesting. Merging. Now, like I said, merging data can be a very expensive operation because most of the time when you do a merge between two tables, you're going to have to do that in memory. Go to another Power Query file that I have open. Here we go. And what I've got here is two queries that connect to the same CSV file. This is a CSV file with 1 million rows in, and I think 6 columns. And it's all full of numbers. So it's just, sequential numbers. It's just a really large CSV file. Now, there's first, there's seconds, they're both merged in memory, but there are 1 million rows. They're exactly the same table. Now, if I do a merge and do a merge as new, so let's create a query that joins these 2 million row tables together on the A1 column, you can imagine that this is going to use an awful lot of memory and it's going to be horrendously slow. And if I was going to sit around here, it would probably take about a minute or so to come back with anything. But it's cached anyway. It's going to be slow. If I was to refresh the preview, it would, I promise you, take about a minute. There's a couple of different tricks you can do. If you only wanted one column, you could simply delete the columns that you didn't need from first and second. But even better, there is a way of doing a merge in certain circumstances which doesn't force the data to be buffered into memory. If you're aware that the 2 columns you're joining on have values that go in sequential order, that are sorted values, you can use the table.join function and then use this join algorithm sort merge. And because you're telling the Power Query engine the 2 columns you're merging on, the 2 columns you're joining on, are already sorted, well, if they're already sorted, then we don't need to buffer the 2 tables in memory because we can just stream the data and then merge as it goes. And this is going to be way, way faster. Now, is this going to be possible in all cases? No, absolutely not. But it certainly does, in some cases, mean that you can really speed up performance. One last demo, I think, because we've run out of time. Let's cancel this. There can also be some cases where changing how you write your M code can improve performance. I'm connecting back to a similarly large CSV file here. And if we look in the advanced editor, what I'm doing is I'm connecting to a really large CSV file. I am sorting that table, which again is going to be really, really slow. And then what I'm doing is I'm saying, get the first value from column 2 in that sorted table. Now, in order to get the first value from the sorted table, we have to sort the table, which is going to take a certain amount of time. Now, this is the expression that gets the first value from the second column. And what I'm doing is, because I know it's a number, I am adding that together 4 times. Now, if I refresh this query, this CSV file is about, I think, 167 meg. And you can see here in the bottom right-hand corner that it is reading the data from that file and buffering it in memory. And it's going to take some time. The reason is because it's going to sort that table 5 times and get the same value out. Now, isn't there a way that we can avoid this, like stop that happening? Well, there is. With scalar values like numbers or bits of text, there's actually some caching that can happen inside the Power Query engine. This doesn't happen for tables unless you use table.buffer, but it does happen anyway. So this is going to be super slow. Let's cancel this refresh. What I can do instead of doing that long reference before, is that I can simply say, let's create a new variable called column 2, which uses that. And then if I just say, give me column 2 plus column 2 plus column 2 plus column 2, gives me the same result, but this step actually caches the result of that expression. And now when I click refresh, it is still going to read all of the data from that file. So it's going to go up to about 167 meg. 169 meg. It's going to sort it. It's only going to do this once. And it will come back a lot faster than before. It will come back in a minute. You'll see that it's not continuing to read more data, but it's going to make it. It's going to make it. There we go, a lot faster. So simply just changing how you write your query, and especially if you're working with scalar values, create a new step just to hold that value. That can allow some caching to take place. All right, that's me out of time. Something I didn't have time to talk about is stuff that happens in desktop. Probably, all right, I'll talk about this very quickly because it's important. There is extra stuff that happens in Power BI Desktop when you refresh a query that doesn't happen in the Power BI service, which means that sometimes desktop can be a lot slower to refresh queries than the actual data set would be in the Power BI service. One of the things that happens is that when you refresh a Power Query, the analysis services engine actually asks for sometimes the data twice. What it's really doing is saying, first of all, tell me what columns are in the query. How do we know what Power Query, which columns the Power Query runs? Well, it needs to do some evaluation on the query. And sometimes that means the Power Query has to run the entire query to get the columns, and then it'll have to run it all over again to get all of the actual data. This doesn't matter if query folding takes place, but if you're working with an Excel file where query folding doesn't take place, well, that can be a real killer for performance. There's no way around this unless you write some very complex M, which I don't want to get into. But in terms of tips that will give you more bang for your buck, the last super important tip that I can give you is that when you do a refresh in Power BI Desktop, it not only refreshes your data set, it also refreshes all of the queries that you see in the Power Query editor and all of the little previews that you see for every single step in the Power Query editor. So if you've got a lot of queries in Power Query and they've got a lot of steps, even if they're not being loaded into the data set, that can really slow things down. And you can stop this happening by, again, going to the options dialog. And yes, Fernando, it's disable data previews. So wait for the options dialog to come back. And it's this background data option. This is the global setting that says, how does Power Query behave normally? I've got it to vary depending on the file setting, and then I can go to data load, and this controls whether for the individual file data previews download in the background. I have literally seen Power BI Desktop go from taking a couple of hours to 30 seconds to do a refresh just by disabling this option. All right, that's me out of time. I guess that probably did take about an hour, but I can stick around and answer questions for anybody who's got any questions. Feel free to come off mute if anybody wants to ask questions.
Thank you. That was great. Does anyone have any questions before we end? I see someone typing in the chat.
Chris, you mentioned that there's a new data flow connector. I've seen people referring to using the Power Apps data flow connector in Power BI Desktop. Is that what you're referring to?
It's the Power Platforms data flows.
Platform. Okay.
Yeah, exactly. So I do have a blog post talking about that and how you can get it to do query folding. So you just search for my blog, data flows query folding, then you'll see a kind of full discussion of that.
The other question I had is for my customer that is a pro data flow user, in those CSV files, there's no stats in the columns. It just says NA. Is that a pro premium thing, or is that because it's all Excel files and SharePoint? Yay me,
yeah.
But
so a lot of those things are only populated if you're in premium.
Okay.
And also a lot of those things will only be populated if you are in premium and you're using the enhanced compute engine. But it's really important to understand if you're using the enhanced compute engine, and you will only be using the enhanced compute engine if you're loading data into the data flow first, and then you've got those computed entities turned on. And I've got a blog post looking at the enhanced compute engine and the performance impact that it can have. It won't necessarily make things faster all the time, but it can do.
Chris, thank you for a great training. I was just curious, I think you mentioned before that to go into this at the depth that this perhaps deserves could take 2 days. Any chance you're thinking about making an actual training like that? Because I would like to take it.
Actually, I did have something like this, I think a couple of years ago when I was working as a consultant. I mean, this was before I put together a couple of days training course when I was working for myself. There wasn't that much interest in it, and if I'm honest, I didn't understand the Power Query engine as well as I do now. The trouble is now I work for Microsoft. I'm not in the business of doing training or selling training courses anymore. Maybe one day I'll write a book on all of this, but if I'm honest, that's a big time commitment, and even after something like 10 years or more of using Power Query, I still don't feel completely confident that I know everything about how it works, and not completely confident in being able to write that advanced book. But I'm still learning. Maybe one day I'll get to the point where I feel confident enough to write a book, and I've got the time to do it.
You need to get the SQL BI guys to do it. You need to turn them on to Power Query.
Yeah. Any other questions?
All right,
Well,
then I will
thanks
stop
for
the
listening.
recording.
Awesome stuff. It's going to be a popular session at SQL Bits for sure.